Welcome to the solutions for exercise 5.1 of Unit 5. Polynomials is published in the Model Textbook of Mathematics for Class, ICSI by the National Book Foundation. In this exercise, we apply fundamental concepts like the remainder theorem, the factor theorem, and synthetic division to solve problems involving polynomial division, factors, zeros, and remainder calculations. Let's walk through the steps for each question. We use the remainder theorem. Let Px to is 3 βασισήκαν to 4x plus 1. Since the polynomial is divided by x plus 2, we set x plus 2 equal to 0, which means x is 2. The remainder is p2. Substituting 2 for x, p2 equals 2 times 2 cubed plus 3 times 2 squared minus 4 times 2 plus 1. This simplifies to 2 times 8 plus 3 times 4 plus 8 plus 1, which is 16 plus 12 plus 8 plus 1. The result is 5. Hence, the remainder is 5. Again, we use the remainder theorem. Let P sa πalisaks 3x to πalisaks. Since the polynomial is divided by x2, we set x2 equal to 0, which means x2. The remainder is p2. Substituting 2 for x, p2 equals 2 to the power of 4 plus 2 times 2 cubed minus 2 squared plus 2 times 2 plus 3. This simplifies to 16 plus 2 times 8 minus 4 plus 3, which is 16 plus 16 minus 4 plus 3. The result is 35. Hence, the remainder is 35. Again, we use the factor theorem. Let P 3 to x minus. We calculate P3. P3 equals 3 cubed minus 2 times 3 squared minus 5 times 3 plus 1. This is 27 minus 2 times 9 minus 15 plus 1, which simplifies to 27 minus 18 minus 15 plus 1. 27 plus 1 is 28, and 18 minus 15 is 33. 28 minus 33 equals 5. Since P3 does not equal 0, x3 is not a factor of Px. We use the remainder theorem. Let Px to is 3 βασισήκαν to 3xm. Since the divisor is x2, the remainder is p2. We calculate p2. p2 equals 2 times 2 cubed plus 3 times 2 squared minus 3 times 2 minus m. This is 2 times 8 plus 3 times 4 minus 6 minus m, which simplifies to 16 plus 12 minus 6 minus m. 16 plus 12 is 28. 28 minus 6 is 22. So the remainder is 22. That means we are given that the remainder is 16. Therefore, 22 and 16. Solving for m, m22, 16. Hence, the value of m is 6. A number c is a zero of a polynomial px if pc equals 0. Let P 3 7xy 6. Check for 1. We calculate p1. p1 equals 1 cubed minus 7 times 1 plus 6. This is 1 minus 7 plus 6. 1 plus 6 is 7. 7 minus 7 equals 0. Hence, 1 is a zero of px. We calculate pr2. p2 equals 2 cubed minus 7 times 2 plus 6. This is 8 plus 14 plus 6. 8 plus 14 is 6. 6 plus 6 equals 12. Since p2 is 12, which is not 0, 2 is not a zero of px. This form is the division algorithm, where r is the remainder and qx is the quotient when fx is divided by xa. We are given a after 2, so we divide fx by x2 using synthetic division. The coefficients of fx are 1, 1, 14, and 11. The root we use for synthetic division is 2. Bring down the 1. 1 times 2 is 2. 1 plus 2 is 1. 1 times 2 is 2. 14 plus 2 is 12. 12 times 2 is 24. 11 plus 24 is 13. The quotient, qx, has coefficients 1, 1, and 12. So qx, xn, to 6 are 12. The remainder, r, is 13. Hence, the polynomial is expressed as f is s, x2, x, to places and 12s, 13. The volume of a rectangular prism is given by the formula. Volume equals area of floor times height. To find the area of the floor, we must divide the volume by the height. Volume, px, x, 3, playonan, to 34 height, x plus 1. We use synthetic division with the root of the height, which is 1. The coefficients of the volume polynomial are 1, 11, 34, and 24. Bring down the 1. 1 times 1 is 1. 11 plus 1 is 10. 10 times 1 is 10. 34 plus 10 is 24. 24 times 1 is 24. 24 plus 24 is 0. The remainder is 0, as expected, since the height must be a factor of the volume. The coefficients of the quotient, which is the area of the floor, are 1, 10, and 24. The resulting quotient is a quadratic polynomial, x, to places des x plus 24. Hence, the area of the floor is x, to plus 10x plus 24 square feet.